It says it's the particle starts from midpoint, right, ma'am? Then we could have taken a cos also, right?
A particle starts from the midpoint between mean and extreme position. You have to calculate the phase constant. So A is equal to, X is equal to A sine omega t.
Ma'am, why are we taking sine?
See, you're asking why we are taking a here sign, this one.
Yes.
See, this is the equation, standard equation of SHM. When the particle is starting from mid position, where is it proceeding? See, whenever the standardized equation for SHM that we take, no, this equation, see. After double differentiation equation, look, for the mean position, when we start, this is the standardized equation is A sine omega t plus phi naught. When the equation has proceeded to somewhere, let's say with some phase constant somewhere, then we take it cos. The standardized equation for SHM involves for displacement, it is sine only. We start with sine. For specifically for the extreme position, we go by cos. Understood? So in questions where it's not mentioned to you, I have told you before also that in questions where something is not mentioned, you take this as the standard equation, because that is known as the equation of SHM for the displacement. So if it starts in the midpoint, midpoint means x is equal to a by 2 is already mentioned, you will use this equation. Otherwise for cos it would be specified. Understood?
Okay.
Okay, this is the equation of SHM. That's why you have the particle's velocity with cos, then acceleration back to sine. For extreme position, those are the special cases. Okay. Yes, in the next question, what is the issue?
Ma'am, for extreme position, we take the equation as a cos for displacement.
Yes, that I told you, no, extreme position I didn't discuss, only I discussed the mean position. So that's why we are taking A sine omega t. Same question it would just have cos. So the angle would be different. Sine pi by 6 is half, you will be using cos pi by 6.
And ma'am, we can take displacement as amplitude.
You can take
Displacement as amplitude
displacement as amplitude.
because maximum displacement, right? Extreme position.
Displacement starting from extreme position. Now you don't know how much displacement has been covered. You are not aware whether the displacement has reached the mean position or not. It is just starting from extreme position.
Okay.
Understood? The
Yes.
displacement is being started from the extreme position. So you are not aware of the fact that is it reaching the mean position. If you are aware of the fact, that means this, then automatically in your calculations you will notice that extreme position is also coming the same and mean position is also coming the same.
Okay.
Okay.
Yes.
Some portions were left of this lesson. Let us complete it today. Very few topics are left. Let's quickly complete this. Yes, Martin, where were you? Your exams were going on.
Mom, I joined the wrong meeting. That's it.
No, not just today. I'm not asking about today. You've been missing out classes. Only Harsha was there. The entire oscillations you didn't attend, Martin. Waves also you haven't attended. Yes, Martin.
Oh, yeah, ma'am. I wasn't with my laptop at the time. So,
Okay, so anyways, we are towards the end of the oscillations only. Last portions are left. So let us just end that also so that you people can start preparing for your exams. Martin, when is your final exam?
I'm between like February and March, like February 22nd till March 8th. The exact date, ma'am.
Okay, okay. This portion we also completed. Okay, we had to start with the combination of springs. It's a very small portion that is left. Let us quickly complete it. So see, if the springs are connected in series, you have to understand two things. Springs connected in series So how to identify whether springs are connected in series? In class 12, when you step up in class 12, you have a lesson current electricity. So there you will see resistors and inductors and capacitors also connected in series and parallel. So for all the series and parallel connection, there is one trick that you have to remember for every case. Because by just looking at the figures, if the figure is such simple figure, then you will look at it and you will be able to figure it out whether it's series or in parallel. Okay, but if it is not written, if nothing is mentioned or some diagrams are very tricky, then it would be difficult for you to identify whether it is in series or not. So if force remains constant, means force is the same for the springs. If the force is same for the spring, like if it is connected like this, and if I pull mass m with some F force, so F will be there for this K2 spring also, and for K1 spring also it would be there. So that's how I have to identify that this is written in series. These both springs are connected in series. So total extension is different. So what will be the total extension? Total extension will be minus F by K1 minus F by K1 minus F by K2. So if I take X common, minus F1 by K1 plus 1 by K2. Okay, so from here, if I take F's value, if I write K2 plus K1 by K1 into K2. So if it will go on the other side, it will become K1 into K2 by K1 plus K2 with a negative sign into X. Now look, is it similar to the equation? I have told you the equation for F is equal to minus Kx. Harsha, answer one thing. Is this in this equation? This is the general equation of SHM. In this equation, what is K? Harsha.
Spring constant.
It's the spring factor. That's what I wanted to tell you. See, this is the generalized equation of SHM. I'm not talking about spring mass system. This is just the spring factor. Now look, this term, F is equal to minus Kx. This constant, this spring factor is now specifically spring constant because this is present in spring mass system. Now the doubt is clear, Harsha?
Yes, ma'am.
Okay, so K equivalent, this is the spring constant for the series combination because this is coming in front of this. So this was the generalized spring factor. Now see, for this system, we have this constant. For different system, we'll have different constant. So K1 by K2 by K1 plus K2. Or best is if you have, this is just for two springs are present, you will use this, you will get the answer. But if so many springs are present, then n number of springs are present, then what will you do? Simply keep on reciprocally adding them. 1 by K1 plus 1 by K2 plus 1 by K3 up till 1 by K nth. Nth means n number of spring. For the number of springs, like this. But when we are talking about parallel, so in parallel combination, the quantity that remains constant is the displacement. That is, this will be the same for all the springs. Here, force applied will be different to the springs, but the displacement that would produce would be the same. Now, one thing that would be very easy to identify is a setup like this. So if a question comes, easy question is there, you will be able to identify. But while performing the calculations, go for this because these rules are very sufficient. In class 12th also, for the current electricity also, we tell such variables and constants only because identification then becomes very difficult. Though in class 12, difficult combinations do not come. Usually simple series and simple parallel combinations are present, but you never know, you should be aware of the same. Anyway, so here if forces are different, so I'll add the force. F is equal to F1 plus F2. This is the total force. This is the total force. F is equal to F1 plus F2. This is the total force. F is equal to minus K1x minus K2x. So F is equal to minus K1 plus K2x. So simply K equivalent is K1 plus K2. It means this is the equation of the spring constant. This is the equation of the spring constant. It means you can, for parallel combination, you can directly add it. K1 plus K2 up till Knet, like this. Understood? Write it down from here. See, the formula for the time period of simple pendulum is 2 pi under root L by G. This is the length and this is the acceleration due to gravity. So on the basis of that, this is one question that, see, rest of the questions are simple. You'll be able to calculate this. But this is a good question that we'll be discussing. Just note this down, then I'll discuss each part. Okay, see, a simple pendulum is placed in a box, calculate its time period when it is accelerating vertically up. It means this box is accelerating vertically up. The issue that comes here, this is not related to SHM now. This is now a question of your kinematics. See, when we are talking about the effective acceleration due to gravity, G is coming downwards, axle minus acceleration, but acceleration is in the opposite direction. So we'll write it as negative. One direction you have to take it as positive, one direction you have to take it as negative. If I take downwards as positive, if I'm taking downwards as positive, so G effective will be G minus minus A, which is G plus A. So simply T is equal to 2 pi under root L by G plus A. This will be it. Second, in the second one, it is accelerating vertically downwards. So acceleration is in the same direction. That is G minus plus A. That is G minus A. So equation will be simple. 2 pi under root L by G minus A. That's it. Second says free fall.
Formula for G effective is G minus A.
G effective is G minus A. See, these are two vectors. One acceleration is downwards, one acceleration is upwards. How will you take the resultant? G minus A, because the angle is 180 degree. But there also we have to substitute the sign convention. So if they are exactly in opposite direction, they get added. Remember relative velocity also we did when two were in opposite, because of minus minus, they used to get added up. Same thing, because we want the resultant acceleration.
Okay.
That's why the effective formula, no, remember like this. Remember like this, it's better. It's G minus A, but with the vectors. That is, you have to put their sign.
Okay.
Third is the free falls case. So free fall, G minus acceleration is also G this time. That is 0. So time period will definitely will become infinite, because the denominator here becomes 0. 1 by 0 is infinity. Fourth part. What's the fourth part saying? Accelerating horizontally. See, if this is accelerating horizontally, acceleration due to gravity is downwards 90 degree. So this time we won't write. See, Harsha, now this time we won't write it as G minus A, right? It means we have our G effective this time as under root A square plus G square. So time period will also be 2 pi under root L by under root A square plus G square. Now this is a very basic formula that we have discussed, that we have written. But see one thing, this is what we have written. In the question, you can get the values of these accelerations also. Okay, this I'll tell you this pendulum thing. Or let me tell you, then you can write down it all together. See, if the question comes to prove the length of the pendulum, if the question comes that you have to prove it, that this is directly proportional or this is an SHM. See, in the derivation, this was the pendulum. We have taken it at a certain angle. This is moving from its mean position to extreme position. This is the tension that is acting along the string. It's making theta from the vertical. L is the length of the pendulum. This is the displacement that has occurred x, because this has not reached extreme position, so we won't take it as amplitude. This is some x. Downwards mg is acting. This angle is also theta. So this becomes mg cos theta. This is mg sin theta. External forces coming. So external force, because we are pulling it towards this direction, so external force is balancing mg sin theta. So F is equal to minus mg sin theta, where you can write sin theta for small angles if approximately is equal to theta. So F is equal to minus mg theta, we can write x equal to L theta from the formula like this. If this is theta, this is the length of the arc, this is x, because this is x, no? This is x, no? Because here somewhere we have extreme position. Okay, So this is the same formula. Radius, remember? It's like this is the acting as the radius, this is acting as length of arc, like that. So that's why we have x is equal to L theta. This is not the length of arc this time. This is like the radius. So F is equal to, when you are writing minus mg theta over here, when you are writing F is equal to mg theta, the constant term that is acting, the constant term which is acting over here, this is equal to, see, minus mg. For theta, I can write it as x by L. So this becomes x by L. Look, F is equal to minus kx. Proven? This equation which was required, we needed this, we have this. Now look, how do we get the, we know this is the spring this is the spring factor. We want to find out the spring constant for the system. If this is the spring factor, what is the spring constant for the system? Omega square is equal to k by m. I've told you, right? Omega square is equal to k by m. So here constant is g by L, right? Constant term here is g by L. How? Look, time period is equal to 2 pi, sorry, mg by 2 pi m by k. So t is equal to 2 pi. This is mg, L will go up, cancelled. T is equal to 2 pi under root L by g. So in the simple pendulum, the spring constant is this for this specific system. So this derivation can be asked. Write down all these things quickly so that we can move on to the YouTube problems. The last system which is left is YouTube.
Ma'am, so this is the derivation for the formula of time period.
Yes, derivation for the formula of time period. You will get the question, prove that the pendulum is an SHM. So how will you prove? Until the equation F is equal to minus kx is proven.
Okay, ma'am. So is mg cos theta equal to the tension?
Yes, tension will balance mg cos theta, right?
Ma'am, how did we get 2 pi under root ml by mg?
Which one? Which one, Harsha?
2 pi under root m by k.
This one.
Yes, ma'am.
Omega and time period have this relation. Omega is equal to 2 pi by t. So omega is under root k by m. So this will be under root m by k.
Okay.
The angular frequency is 2 pi nu, no? Linear frequency. And
Yes.
linear frequency can be written as 1 by time period. Rotation, try to recall circular motion. So that's why this is this.
Okay.
See, in a U-shaped tube, if you have this fluid and you apply pressure from here, the same problem that we had seen in the mechanical properties of fluids, then what will happen? The fluid will rise from here, the fluid will fall from here. Then the fluid will fall from here, it will rise from here. So there will be a to and fro like this oscillation which will be produced. So it is an SHM, but you have to prove that this is an SHM. So firstly, the prime condition you have to prove if it is following this equation. So let's say the height is this. So length of the tube is 2h, L. Understood. Area of the cross section is A. This is the height, length we are taking. This is h, this is h. This side is also h. So that's why 2h, which is the length. Density of the liquid is rho. When we are talking about density, it's rho. So for the U-tube's volume, This will be area into the length, area into 2h, mass of the liquid in the U-tube. See, mass will be the volume. See, this is the volume, this is the mass. So mass of the liquid in the U-tube, this will be 2h multiplied to the density. We'll multiply it to the density. So look here. This says that the fall and rise of the liquid, that if it is depressed by y amount, level of liquid is depressed by y amount, so it will rise by y amount only. So this is what is meant by the oscillation, liquid's oscillation. So it means the entire length that we are referring is 2y, y plus y. Liquid is filled in the length 2y, which offers the restoring force. So when we are talking about the restoring force, we will not be just talking about it as y. F is equal to minus 2ya into rho. Why 2y? I have told you. Understood? So F is equal to minus 2a. See, density, this is 2. When we are writing it, when we are talking about it, y, if you say separate it, if you segregate it, 2a rho g, you'll be writing it as 2a rho g. I'm just shifting the term. I'm just rearranging it. Understood? 2a rho. This is mg. There has to be one g also here. This is mass into g. So I'm just rearranging the term. I'm bringing y out. So F is equal to minus ky is proven, where your constant is 2a rho g. Why? See, F is equal to mg. Mass was 2h rho a. This was the mass multiplied to g. Understood? This was 2h rho ag. What was the height here? The height was y that we had chosen because of the oscillation. Time period is again 2 pi under root m by k. So here the mass, the constant that we are getting is, why are we writing this? Because of the same equation, omega is equal to under root k by m. Understood? See, this, I hope you are getting why we are writing it as mass into density. Rho 2hg. 2h is the height that we are taking. Same thing, this is the derivation. One more thing we have, floating of a cylinder. Do one thing, write it down, then we'll discuss the floating of cylinder. All these are just derivations. You have to get the equation back. Floating of cylinder is shorter than this. Quickly write this down.
Ma'am, can you scroll up? Ma'am, how did we get h by g?
See, this is entire mass, right? This part is the entire mass. Here, see, this is the mass, you are having G. So T is equal to under root M by K. What is the formula for K? K is 2A rho G. All right. Density, how can you write density? You will go reverse. You will go reverse. Density, what you can write density as mass by volume, right? From there, mass will be cut. Volume can be written as area into height. Area will be cut, only height will be left.
Okay.
Okay, now coming to floating cylinder. oscillation of a floating cylinder. This is a cylinder. So if we drop it into water, we know that it will bounce back. So that we are not talking about buoyancy right now. We're talking about the to and fro motion of a cylinder. That is the oscillation which is occurring, oscillation of a floating cylinder. So when cylinder is further immersed by Y, it started oscillating. Now, mass is equal to, this is the volume into density. Force is equal to mass. All right. So now I'll not be writing in general terms. Area, we know area of cross section. I've taken it as A. Length of the cylinder. Let's not take the length. Let's take the displacement that is occurring. So if it is displacing by Y, it will rise by Y here. So Y will be the displacement that we are referring to. So Y. Density of the liquid, I have taken it as sigma. So here also I'm taking it as sigma into G. So F is equal to, now when you put, this is the mass. So this is F is equal to A by sigma G. Again, you know the value of K, the constant term that you're getting. The constant term that you're getting, this is A sigma G. This is the constant that you're getting. Now, when you substitute it in the formula, you get T is equal to, you have T is equal to pi under root M by K. Formula will be T is equal to under root L rho by sigma G. Same thing, you've just substituted this value. Write this as well. Okay, one more example is left, and just a small topic for oscillation is left. So now we'll be able to complete this on Tuesday. Tuesday, let us complete, because now time is over. A very small topic, so not 1.5 hour class will not be taken. A short class I'll take. 30 minutes to 40 minutes class, whatever topics are left, we'll complete that. But apart from that, if you have any doubts, you can let me know from any of the lessons so that we can arrange that also. All right, you can leave. Thank you so much.